Hi, welcome back. Today we're going to try this exponent problem. Whenever you get a term in an equation where there's a variable as the exponent, it always looks difficult. But actually, this is easier than you think. So we have 125 to the x minus 2 equals 25 to the power of x plus 5. How are we going to do this? Well, the first thing to notice is that 125 is 5 to the power of 3. And 25 is 5 to the power of 2. So this becomes 5 to the power of 3 to the power of x minus 2. And this becomes 5 to the power of 2 to the power of x plus 5. Now there's an important relationship you need to know here. If you have a number that is raised to a power, and all of that is raised to another power, then that is the same as that original number raised to the power of the two original powers multiplied together. Therefore, we can rewrite this as 5 to the power of 3 times x minus 2, and we can rewrite this as 5 to the power of 2 times x plus 5. Now there's another relationship you need to know. If you have a number raised to, say, the power of x, and that equals the same number raised to the power of y, then x must be the same as y. We can now write this as 3 to the x minus 2 equals 2 to the x plus 5. Therefore, 3x minus 6 multiplying out is the same as 2x plus 10. If we now deduct 2x from both sides, we get x, and if we add 6 to both sides, we get 16. So that's it. Our answer is 16. And I think you'll agree, if you understand these two relationships, that wasn't too bad. Just as a side note, if we wanted to prove that this is true, what we could do is take the log of both sides. So we'd have log n to the x equals log n to the y. And if our base, we choose n, and we bring the x down, we end up with x log n of n equals, bringing the y down, y log n of n. Now log n of n is 1. So this basically disappears, and we're left with x equals y. Okay, hope you like that. If you did, please subscribe and check out my other videos.